Good morning, guys. Welcome to the most boring YouTube channel ever. Just let me get the lights and then we'll get started. Okay, so I think you probably found that the last lesson on just figuring out if something was a function or not was probably pretty straightforward. Today's lesson is maybe a little bit more difficult just because stuff looks weird, but if you're comfortable with substituting values into an equation, values for x or values for y, and then simplifying, it's no more difficult than that. Okay, so when we deal with functions, we are dealing with a different way of writing an equation, slightly different, and it's called function notation. And I hope you can see this behind me. It doesn't look terribly bright, but hopefully you can see it. Anyways, it's called function notation, and if we had a regular old equation like y equals 2x, which remember simply means that the value of the dependent variable is twice as big, right? 2 times is twice the independent variable. So if we were to set up a table of values, and I'll do this really quickly, where we had values for x, remember the x is always on the left side, and values for y, then if I had an x value of 0, then my y value would be 2 times 0, or simply 0, right? 2 times 0 is 0. Well, what about if I make my x value 3? Well, then if my x value is 3, my y value will be 2 times 3, or 6. And I can keep doing that on and on for infinity and generate an infinite series of ordered pairs, which when I put on a graph will give me a nice straight line. Okay? So when we're dealing with function notation, we just write it a little bit differently. So instead of writing y equals 2x, we're going to write f at x equals 2x. Now, how is this first one different from the second one? Well, very simply, instead of writing a y, I've simply replaced it with this weird looking thing, f at x. And you can see in the little cartoon over here, it tells you f at x is just another way of writing the variable y. Okay? There's nothing terribly deep and difficult about understanding it. It's just instead of writing y, you're going to write f at x. Okay? And that allows us to do a couple of little things like plugging in values for variables and stuff like that, which we'll get at right now. So, it says here, if f at x equals 3x plus 4. That's exactly the same as saying, if y equals 3x plus 4, and then it says, figure out, if f at x equals 3x plus 4, what would f at 1 be? This is telling you, substitute 1 for x and find the value of y. In other words, wherever we see x in this expression, we're going to substitute 1. So our new expression or equation will become f at 1 equals 3 times 1. Notice I've just substituted a value of 1 wherever I see x, plus 4. So again, notice that this is just like our original, except I've subbed in a value of 1. So then it's just a matter of simplifying. F at 1 equals 3 times 1 is 3 plus 4. F at 1 equals, sorry, 3 plus 4. F at 1 equals 7. Okay? So going back to the table of values that I just had up there on the front, what that means is we now have an ordered pair. It has an x value of 1 and a y value of 7. Okay? So you could write your solution like this, right? When when x equals 1, y equals 7. Any questions? We'll do one more because sometimes they get a little bit more complex. So why don't we try and do number 2. And we'll do 2b. Okay? So here's our original expression, and remember all that means is y equals 2x squared plus x minus 5. And what they're saying is, if x equals negative 3, then you sub negative 3 into your original equation wherever you see x. So this would become f at negative 3 equals 2 times negative 3 squared, right? Instead of x squared, I have negative 3 squared, plus negative 3, right? There's another x, minus 5. Okay? I'm just going to shut off this overhead light and see if that makes a difference. I don't know if it's any more visible. Whatever. Okay, so simplify. Remember, order of operations says you always deal with exponents first. So this will become 2 times negative 3 times negative 3 is positive 9. Plus negative 3 is the same as just saying minus 3 minus 5. 2 times 9 is 18, minus 3, minus 5. So, f at negative 3, so in other words, the value of y when x equals negative 3 becomes 18 minus 3 minus 5, or 10. And again, you can write this as an ordered pair, where your x coordinate is negative 3, and your y coordinate is positive 10. Okay? How we doing? Okay, so what I'm going to do is I'm going to skip this stuff for a second, and we'll take a look at some of these. Now, the first thing you need to notice maybe we'll move on a little bit further, just a sec. Let's take a look at number 11. Okay, now number 11 is a little bit different. Number 11 says you have this equation, g at x, or y, equals 5x minus 2. Now in this case, they're not asking you to find the y value like the last question we were doing. In this case, they're saying if your value for y equals negative 17. So what they're saying here is if y equals negative 17, find x. Okay? So it's a little bit different. They haven't given you a value of x. Instead, they've given you a value of y and said, find x. Okay, so we'll do that over here. So what we have is g at x equals 5x minus 2. And we've been told that g at x equals negative 17. So where you see g at x, you're going to substitute negative 17. Okay? Let's just, there we go. Okay. You're going to substitute negative 17. The right side stays 5x minus 2. And you can see now we just have the one variable, x. We have to solve for x. So remember what that means is you have to isolate x. So you've got to get rid of everything on this side except the x. And order of operations says the first thing we're going to do is adding and subtracting stuff. So minus 2 plus 2 equals 0. You're left with 5x. On this side, negative 17 plus 2 is negative 15. And this is the point where I would ask you, if you were actually in front of me, what's the last thing we have to do to get x all alone? Well, we have to get rid of this 5. And because it's multiplied by x, we have to do the opposite operation. We have to divide. 5 divided by 5 leaves us with 1x. Negative 15 divided by 5 gives us negative 3. So, what this is saying is, if y equals 17, x equals negative 3. And just like with the last one, we can express our answer as an ordered pair, where negative 3 is our x coordinate, and negative 17 our y. Okay? I think maybe we should try one more of these. Okay? So, for b, the only difference is we're being given a different y value, right? This time we're being told y, or g at x, equals 23. So, we're going to do exactly the same thing. It's just that as a first step, instead of plugging negative 17 in here, we're going to plug 23 in here. Because for this one, we've been told g at x equals 23. G at x is 23. Okay. And we'll just change things up here. Okay, so again, to isolate x, the first thing we do is add 2 to both sides. That doesn't change. Our answer, of course, is going to change because we're starting with 23. So 23 plus 2 is 25. Our next step, just like before, we want to get x all alone, so we want to divide both sides by 5. 5 divided by 5 still gives us 1x. This time, though, it's 25 divided by 5, and that gives us 5. So, we get a different ordered pair. When x equals 5, y equals 23. Okay? So, if you're given a value for your function, g at x, that means they're telling you what y equals. On the other hand, if they give you something like this, where they actually plug a value in for x, then they're telling you what x equals and saying, okay, smart guy, solve for y. Okay? So if you see a number in the brackets, sub it in for x. Whoa. If you see an x in the brackets and they're saying that it has this particular value, they're giving you a y. Okay? Now, if we look at it on a graph, there we go. If we look at it on a graph, you can see that, as I was saying earlier, all you're really looking for is an ordered pair. So for instance, here it says, given the graph at the right, state f at 0. What that means is state the value of y when x equals, in this case, 0. So you go to your graph. Remember the x coordinate is left and right. So here, this point right here has an x coordinate of 0. What is the y coordinate? Well, if you go up, you'll see that this point has an ordered pair of 0 for the x, and you have to go up 1, 1 for the y. Okay? So f at 0 equals 1. Or y equals 1. What about b? Well, it says f at 2. Again, you're looking for the value of y when x equals, in this case, 2. So let's do that. Go across to 2 on the x-axis. This point is 2 across and 3 down. So this one would have the ordered pair 2 and negative 3. What does that mean? The value of y when x equals 2 is right there, negative 3. How about D? This one says the value of y when x equals 4 is, well, first of all, we got to figure out where x equals 4 falls. Well, again, 4 to the right, positive 4, takes us to this point. The value of y when x equals 4 would also be 1. Okay? So, 4 across and 1 up. So, the value of y when x equals 4 would be 1, right? I hope that kind of made sense, okay? Think of it as just, an ordered pair is just a direction to get you from the origin to any given point. So to get to this point from the origin, you have to go 4 to the right and 1 up. 4 to the right and 1 up. Okay? Any questions? Okay. Let's just try, oh heck, let's try one that's really weird just to show you. That this can get really weird. So what about this? Just let me move it up a bit. It says, if f at x equals 4x plus 3, again remember, all they're saying is if y equals 4x plus 3, find f at 3t minus 1. So, maybe you just did this, but this is just a value for x, okay? Just like something simpler like f at 2 would mean you're going to take 2, you're going to sub it in wherever you see x. This doesn't mean anything different. The nice thing about math is the rules apply for the same for the easy things as they do for the more difficult things. So, what we're going to do is we're going to say f at 3t minus 1 equals 4. Then, where you see x, we're going to plug 3t minus 1 plus 3. Again, notice that where I see x, I've plugged in my value for x. And then you just simplify. Okay? So remember, we've done this, right? You apply the distributive rule. You go 4 times 3t is 12t. 4 times minus 1 is minus 4. And then bring this down plus 3. We can simplify some more. These are like terms. They can be combined. We can't combine anything with this because nothing else has a t in it. So 12t minus 1. So f at 3t minus 1 equals 12t minus 1. So when x equals this, y equals that. Okay? Just one more question before I let you go. Another graph. It's just this time they're telling you to notice there's no number substituted for x here. In this case, they're telling you if y equals 5, remember this f at x just means y. If y equals 5, find x. And you do exactly the same thing. You go to your graphed line, you find the point where y equals 5. Well, remember y is above and below. We're on the vertical axis now, so y equals 5. That's the point right there. That's 5 above the x-axis. Well, when y equals 5, what does x equal? Well, this point is 1 to the left, or negative 1. Okay? So, when f at x equals 5, x equals negative 1. And you could write that again as an ordered pair, negative 1 and 5. Sometimes you will get, like with D. Let's do D. Okay? So for D, again, they're saying if y equals 1, find x. Well, y equals 1 simply means we're going to go up 1, right? Positive is up, negative is down. So we're going to go up 1. Now, the first thing you'll notice is if we go up 1, there are actually 2 points that are up 1. Okay? Don't worry about that. All that means is there's 2 correct answers. Okay? So, when you go up 1, there's this one and that one. Okay? The value of x for this one is 1 to the right, or positive 1. And the value of x for this one is 3 to the left, or negative 3. So 2 right answers. So for this one, you would have x equals either negative 3 and positive 1. Okay? I hope that helped you. Again, if you're having difficulties, we'll be continuing along with these. There's one more lesson to do for this chapter, and we'll take a look at that at a later date. Bye.